In lesson 8.1, we're going to be talking about the areas of parallelograms and rectangles. And as we look at the rectangle to the left, which is 8 units wide and 3 units high, in order to find the area of a rectangle, we multiply the base and the height together. And don't forget that bases and heights are always perpendicular. Hence, you notice the right angles in red on the lower right-hand corners of these rectangles. In this light blue case, as you see, we have 8 times 3, which is 24, and 24 would be the area of that light blue rectangle. Also, don't forget that area is always measured in square units, not the number, but the units, and if the sides were in centimeters in this case, then the area would be in centimeters squared, or in other words, 24 centimeters squared. So the way that you would write your answer is 24 cm squared, not 24 squared centimeters. So this is our answer. Looking at parallelograms, what we notice is that parallelograms actually have the same exact formula. In order to find the area of a parallelogram, it's still base times height, just like a rectangle. And down below, we kind of see why that is. If we were to take a perpendicular and look at the light blue parallelogram with a teal triangle sectioned off, and then slide that teal triangle to the right-hand side, we would see step 2 and step 3 occur where we actually produce a rectangle. And that's why the area of a parallelogram, just like a rectangle, we multiply the base and the height. So in this case, just like in the case with the rectangle on the previous slide, the area would be 8 times 3, or in other words, 24 units squared. Look at the fact that we have this 3 being the perpendicular height. That's very important. If we had a label of 4 here for the side of that parallelogram, we would not be multiplying the 8 by the 4 because those two numbers are not perpendicular to each other. So we cannot do that. The base and the heights must always be perpendicular. In this last slide on this lesson, it's kind of a multitask, if you will, situation. And so we see a figure here to the left, which has 3 parts to it: a triangle on the top, a rectangle in the middle, and a triangle on the bottom. And if we wanted to find the area of this particular shape, then first of all, this 8, which looks like it's off to the side, is actually supposed to be the length of this side of the rectangle, or in other words, the triangle as well. We can separate that shape into 3 pieces. To the right here, you see a triangle in red on the top, a light blue rectangle in the middle, and a little bit darker blue triangle on the bottom. And if we look at separating those 3 pieces, we notice that in the red triangle, if we were to calculate the area, we know that the area of a triangle is base times height divided by 2. So the area of this red triangle would be 8 times 3 divided by 2, or in other words, that's 24 over 2, or 12. For the light blue rectangle, we see that we have base times height, or in other words, 8 times 4, which is 32. And for what I guess I might call the teal triangle, we have the base, which is 8, times the height, which is 1, divided by 2 for the area, or in other words, 4. And when we add all those up together, the 12, the 32, and the 4, we find out that in the end, the area total for that shape that we started with would be 48 units squared, whatever they might choose for the units. 12 and 32 being 44, plus 4 more, making a total of 48. So strategy, when you see a complicated shape, split it up into shapes that are more basic that you know the areas for. So far, we for sure know the area of a triangle is base times height divided by 2, and the area of a rectangle is base times height.